Lecture 6, the Framingham Heart Study, and this is part 2 and the last part of this lecture. So after having an introduction to the Framingham Heart Study plan and having the data set, now we are going to apply analytics to predict and prevent heart disease. So to do so, first we need to define the risk factors, and then based on that we need to have data, so we need to collect data. So then based on the data we can predict the heart disease, right? And then maybe we need more data to validate our model, and then based on the results of our validated model we can define interventions in order to prevent heart disease. Okay. In this model, we are going to predict 10-year risk of CHD. CHD is the coronary heart disease. Coronary heart disease is a type of heart disease that develops when the arteries of the heart cannot deliver enough oxygen-rich blood to the heart. And CHD is the leading cause of death in United States from since 1921. So in the world, although we have a significant decline in the death rate, I mean adjusted death rate as 60%, but unfortunately still we have significant rate of death because of CHD. For example, in 2008, there was 7.3 million people died from CHD. Okay. The first step is defining risk factors. Risk factors are variables that increase the chance of a disease. Okay, and we know that identifying important risk factors is the key to successful prediction of CHD. Okay, so now let's see what are the risk factors for CHD. Okay, in order to identify the risk factors, here we consider the risk factors collected in the first data collection for the Framingham study. So in this data set, we have anonymized version of original data, and also we have 4,240 participants in 1956 with ages of 32 to 70, and all were free of heart disease at the start of the period of 10 years. I mean, at the time, 1956. Okay, and then they were monitored for 10 years, starting from 1956 to 1966. They were monitored to see if they experience heart disease. Okay, so here are the risk factors. In the category of demographic risk factors, we have male, age, and education. So for the male, we have binary values here. So 1 for this variable means the sex is male, and 0 means female. And for the age, we have the age in years at the first examination. I mean, at the start of the study. And for education, we have some high school. So I mean, the value of 1 for this variable means having some high school, and the value of 2 means having some high school or general education development, GED. And the value of 3 refers to having college or vocational school education, and the value of 4 means having college degree. Okay, so these are the demographic risk factors we consider here. Okay. The second category of risk factors is behavioral risk factors. Here we have 2 variables, current smoker and cigarettes per day. The current smoker is a binomial variable, so value of 1 means the patient is currently a smoker and 0 not. And the cigarettes per day is the number of cigarettes per day. Okay. And the third category is medical history risk factors. So here we have four variables. BP meds means being on blood pressure medication at the time of first examination, and prevalent stroke means previously that patient had a stroke, and prevalent hype means currently being currently hypertensive, and diabetes means currently having diabetes. Okay, and here we have the fourth category of risk factors, which is about physical characteristics and health situation. So we have total cholesterol here, and systolic blood pressure, diastolic blood pressure, BMI as body mass index, heart rate, beats per minute, and glucose, blood glucose level. Okay. So now we are ready to implement our analytical approach here. First, we randomly split our patients in the data set into two subsets as training and testing data sets. Let's assume the ratio of 75% of data set for training and 25% for testing. Okay, so here we apply logistic regression on the training data set in order to predict whether or not a patient experienced CHD within that 10 years study period. Okay, and then we will evaluate the predictive power of our model on the test set. Okay, so let's do this in R. So we will do this in R separately in another recording. So here I just have a summary of results obtained by the logistic regression model in the next slide. Okay. So here we have the summary results of our model, logistic regression in R. And as you see here, we have the list of significant independent variables as male, age, cigarettes per day, diabetes, total cholesterol, and systolic blood pressure. Okay, and there's the remaining of the independent variables are not significant, so they were eliminated from the model. Okay, and here we have the performance of the model over the test data set. So I see here we have 775 cases as value of 0 means they didn't experience CHD over that 10 years period. And here we have correctly predicted 771 of them. So we have just error for 4 of them. But for the positive cases, we have 139 cases as positive. They experienced CHD over that 10 years period. And here we predicted just 9 of them. So we have error for 130 of them. So in total, our accuracy on correctly prediction is 0.8534. Okay, so in order to have an idea that how is the performance of our model, let's consider a baseline method here. So the baseline method could be assuming not experiencing CHD for all patients. Okay, yeah, we can say none of the patients experience CHD. So by having that, if you see here, then we will have just false prediction. The value of 0 for all patients. So because of that, the accuracy of baseline method would be 771 over 771 plus 4 plus 130 plus 9, right? So then it becomes, let me have the value here. Yeah, it becomes 0.8435. So as see here, our model is just slightly over that this ratio, so we can say in terms of accuracy, there is no significant difference between our model and the baseline model. But if we consider the AUC here, the AUC area under the curve of ROC curve, we have 0.7178. So if you refer to the interpretation of this measure here, it's somehow the probability that we can correctly predict the result of a patient. Okay, I mean having correct prediction. So by this probability, we can say, okay, our model can be somehow reliable, because with over 70% chance or probability, we can correctly predict the outcome. Okay. So as we discussed, our model rarely predicts 10 years CHD risk above 50%. So because of that, the accuracy of our model is so close to the accuracy of the baseline method. So no significant difference between our model and the baseline. But when we refer to AUC, then we see a strength of our model over the baseline method, because with 71% chance or probability, our model will differentiate low risk from high risk patients. Okay, and another advantage of our model could be considering the response obtained by the logistic regression model. I mean, don't classify the outcome to be 0 or 1. Just consider the response, which is a value between 0 to 1. And then we can interpret that response as the probability for actually having CHD for a patient. And based on that probability, we can consider some level of medications. Okay. And another advantage of our model could be using that to define the significant variables, and then based on that we can suggest some interventions. So if we consider the significant variables like male, age, so we can do no interventions on those variables. But when we consider the smoking and diabetes and also systolic blood pressure and also total cholesterol, we can define some interventions on these risk factors in order to prevent the heart disease. Okay. So after having a validated model in our analytics approach, we are at the final step, so define interventions using the model. So using the model, we can define the important or significant risk factors, and then based on that we can define appropriate interventions. So now interventions for blood pressure and total cholesterol. So drugs were developed to lower blood pressure. So in 1950s, the diuretic chlorothiazide was developed. Okay, so Framingham heart study gave Edward Fries. So Edward Fries was an American physician and researcher who received the Albert Lasker Award for his studies on treatment of hypertension. Okay, so yeah, this study gave Edward Fries the evidence needed to argue for testing effects of blood pressure drugs. And now we have a market of $1 billion for diuretics worldwide. Okay, and drugs to lower cholesterol in 1970s, first statins were developed. Okay, and so the study of 4,444 patients with a CHD, on this study, the observation is having 37 risk reduction of second heart attack for those patients because of using statins. Okay, so and now we have a market of $20 billion for studies worldwide. Okay. So let's wrap up this case by having the current research directions on the Framingham heart study. So here we have the second generation enrolled in this program in 1971 and third generation in 2002. So this enables us to study the family history as a risk factor to see if it's significant or not. And also we have more diverse cohorts begun in 1994 and 2003. And also now we are able to consider the social network analysis of the participants as a, a potential risk factor, and or maybe the impact of social network on the risk factors. And also the genome wide association study linking studying genetics as risk factor is possible now. So these are the research directions on the Framingham Heart Study Program. Okay, thank you.